Good evening, everyone, and salam Sujatra. Welcome to Mape's Talk today. Efflorescence, debonding of tiles, and water seeping through the roof are headache-causing issues which could plague your property. These are often caused by a combination of factors in both the tile installation and waterproofing works. Find out from our expert who will speak about the challenges involved and the areas we need to pay attention to in order to avoid them. We have with us today a special invited speaker from MAPE headquarters in Italy, Mr. Marco Ebelis. Marco is a graduate from the Milan Higher Technical Building Institute and has many years experience in ceramic and natural stones and waterproofing supporting MAPE technical team. It is our privilege to have him sharing his expertise to us today. After the talk, our team is all ready to assist with any queries you may have at our MAPE stand. Do make your way over to our stand, a live chat with us. So without further ado, let me bring Marco to join me on screen.
Hello, Priska. Hello, everyone. Thank you very much for the invitation. I'm very glad to be here with you today.
Hi, Marco. How are you today?
All right. Thank you so much. It's a good privilege for me to be here with you and all the people connected to share this interesting issue, technical issue concerning the subject that you announced right now.
Okay, Marco. So I will pass this floor over to you.
Thank you very much. Okay, we can start. And what we see today together is, as has been said right now, tiling deck, and I would say large outdoor flooring made of tiles of stone. And I have to say, the key takeaways that you see on the picture here are really suitable for this meeting, for this seminary, because you see the challenges of a tile deck, and I would say also for large terraces and balconies, in any place we have outdoor fixing tiles or stone. And really, this can be a challenge, a real challenge, because of the many factors that we have to take into consideration when we project and when we do the real practical application of such a flooring in outdoor situation. Some of these important factors are, for example, as you can see, the waterproofing systems or the tiling installation. By our experience, the waterproofing systems nowadays became more and more important in the stratigraphy of an outdoor tiling, no matter if it is tiles or stone or what else. The waterproofing system, if it is well done, can prevent many defects on the aesthetical surface, but also technicals. And the same for the tiling installations. Which kind of material, which kind of method we can use today. This is a detail very important because in the last 20 years, we can say, the main tile producer all around the world changed a little bit the technology, the way they produce tiles. And today you can see also large format tiles with thinner and thinner thickness. Without mentioning also the natural stone. Also the natural stone producers changed a lot the technology to produce the slabs. And in fact, you see on the market, sometimes it happens, we see natural stone slab with thickness lower than 2 centimeters, even 1 centimeter, which is very low to be a natural stone. And these details, this consideration bring us to think that also the way we apply the tiles and we do the job may change through the years. And all of this well connected together to avoid one of the most known problem we face in the job site all around the world, we have to say, which is preventing efflorescences. What is efflorescences? How can we prevent that? How do we have to make a proper communication between the project phase, the application phase, to communicate and talk each other to avoid this kind of problem? Well, when we do the project for an outdoor installation of tiles or stone, especially when a large surface has to be covered, we have to consider that this kind of application are subjected to, for example, outdoor environmental conditions, The heating of the sun, the cold temperature, the high temperature, the humidity, all these things can affect the flooring. Not only the flooring, even what is below the flooring. For example, the slope, the screed, the concrete, and everything is moving a little bit. So this kind of application are subjected to a stressful, which is much higher than what we have indoor, for example. And when we do this kind of job, no matter it is a private application or a public application, our aim, our purpose is to have an application, a floor, and sometimes also a covering that will stay as long as possible, as long as the integrity of the concrete where it is applied. And if we have a good communication between the project phase and the application phase, many times this can happen. We can have job site, we can have referential applications that were done 20 years ago, even more, with no aesthetical problem and no technical problem. Anyway, we have to say that the reality sometimes is different. It's very different. Sometimes we face situations like this, where efflorescences affect significantly the aesthetical effect of the job that we have done, but not only aesthetically, even technically. The efflorescence comes out from the substrate through the grout, through the joints between each slab, each tile on the floor or on the wall even, coming out with white spots, white deposit on the surfaces. But consider that what you see here in the angles, in the corner, in the joints, in all these places is just the last visible part of the efflorescences. We have to know that efflorescences start to be created even before, sometimes even before rising out of the flooring or the covering, inside the concrete or even inside the screed or the bed mortar that we have used to fix the flooring. And in that case, the crystallization of the efflorescences when water evaporates will destroy the compactness of what is behind the flooring, with not only aesthetical defect, but more than ever, a technical problem, debonding, detaching, an issue like this. And there are some other circumstances that can make even worse this kind of situation, which is, for example, a weakness in the substrate. A weakness in the substrate, in the preparation of the substrate, it's a problem very linked to the outcoming of efflorescences. For example, if there is a lack of cement into the screed, into the bed mortar, if there is no projecting of expansion joints, control joints, if there is some detaching element created on the surface of the screed or the concrete, all these things can make worse the situation connected also to efflorescences. Because if you see here in the picture, for example, where we have a joint, but we have a large crack very close to the joint, of course, in these points, we will have higher, deeper penetration of water, but not only water, even all the environmental condition, aggressive situation that can drop over the surface, penetrating in the substrate, and once it's inside, the situation can very, very worse. In this kind of situation, who can be considered responsible for this? We are not looking for the responsible. We are looking for a proper solution in case of these problems, even better, a proper project to avoid this situation. Look at the picture on the right. We have a joint, expansion joints, but we have a large crack. Now, some questions rise naturally. What is an expansion joint? Who has to decide where I have to do the expansion joints? And according to your experience, why we have such a large cracks very close to a joint, and behind we can see a pillars on the close to the wall? Now, I tell you these details just to get deeper into the conception that the tiling of a deck, of a large balconies, of a large terraces is not only a matter of application or products, which is very important, but also a step back to think of what are the weakest and the difficult details that we have to consider before the application. Even because there is another reason. The reason is that when we have a defect like this, like efflorescence, like cracking with penetration of water, what is gonna be to damage is not only the floor, it's not only the outcome of the tiling or the stone that I have placed on the surface. Many times, everything which is surrounding the structure can be affected. Many times, maybe in your experience in constructions field, you have seen this kind of situation. Now, it's not the subject of our meeting today, but it's important to understand that a lack of good application of project in the first phase of waterproofing systems and checking details can create further problem. In this case, we have the detaching of the paint under the floor, the detaching or bubbling of the leveling compound if they've been used. And then even worse, we have the degradation of concrete. And the metal bar soaked into the concrete structures start to be rusty. And through the years, the rust will push out the remaining concrete. And then, in general, we will have a weakness, a huger damage of all the structure, not only of the flooring of the terraces that we are doing. So in this case, anytime we consider the reparation of the concrete, by chance we may have the occasion to repair this kind of material, we have to remember that they are connected to the waterproofing system that can be applied over the surface, not only to prevent efflorescence, but also to avoid this kind of final results. And in case you may decide to apply a special floor, for example, you want to fix natural stone on your surface, on the deck, on the balcony, on the terraces, good, but a lack of application of proper type of system, of a fixing system, can create not only the detachment that we've seen there, but with natural stone can also create staining problem. As you can see in the picture, this is marble. Maybe you know this, not all the natural stone are subjected to staining or deformation, but some of them, especially the marble family, can be subjected to changing the color when there is humidity under the floor. And in this case, unfortunately, there is not very much to do to save the situation when the damage is done, because this kind of change in color is not a superficial changing. It's about all the thickness of the stone, because the changing of the color is coming from the back, from water rising to the absorbent marble, passing through the thickness of the marble and reacting with some components into this natural stone that, when in contact with water, with air, CO2 for example, they turn out to become yellow, red staining, and we cannot go back to the result. So just this scary introduction is just to pay attention to the details of some part of the job we do with the floor for natural stone or tiling in an outdoor surface, even a large surface. Now, let's go to concentrate a little bit on the point that we are discussing in particular, which are the efflorescences. What is an efflorescence? What do you think is an efflorescence? Why we have the rising through the joints of these white spots, crystal depositing all over the surface, not only where we have the grout, the joint between each tile, but even when we have, for example, the drainage, a deposit of water in the drainage system, many times also in that place we have a rising of white spots and crystallization of this material on the surface. And anytime I wash it with water, maybe I can remove it, but after a few days, I would say after a few hours, again, we have this kind of problem. So let's try to take the problem from the beginning. What is it? Well, by the chemical point of view, the analysis of all the efflorescences that we have done through the years, but not only MAPEI, the company in this field, the construction field, that are really interested in knowing what is the problem, we analyze this white deposit, these white efflorescences in the lab, in internal lab, and with microscope, electronic microscope to check what really is it. And in the main of the cases, the most common efflorescences we found out it is calcium carbonate. But the calcium carbonate is the result of another reaction that happens not outside, but into the substrate, which is the reaction between the calcium hydroxide and the carbon dioxide, so the CO2. What happens? Simply, the most of the cement-based binder, or would say the most of the cement-based system that we have below the fluorine, they create naturally, because of a result of hydration of cement, they naturally create a calcium hydroxide compound. But this calcium hydroxide compound, when we have a lot of water into the mix, or when we have a lot of water coming from the ground, rising up to the thickness of the bed of mortar that we have prepared with cement, well, the water evaporating will bring the calcium hydroxide, which is naturally produced by many Portland cement system, up to the surface. And when in contact with the CO2, so the carbon dioxide, it changes its composition, becoming calcium carbonate plus water. But of course, water is water, and then it will evaporate, and what remains on the surface is exactly calcium carbonate. By far, your experience, and also our experience, and also the customer experience, we can wash the surface with water coming back to the previous reaction, and we don't see anything. But as soon as the water evaporates, again, we have the calcium carbonate on the surface. So, what can we find to link this situation to the formation of the efflorescence? But let's give a look to this stratigraphy. It's a very, very simple image that we can share together. What is it? Actually, this is a standard, normal stratigraphy that we find today, even today, and that has been used for plenty of years, for many years to the past, in construction fields to fix tiles. So we have normally a concrete substrate, the concrete structure. Then we have, I hope we should have a slope to evacuate the water, to drain the system. Then we have the waterproofing systems. In this case, we mentioned the bituminous waterproofing system, but it's not only this one. It can be any kind of waterproofing systems. The bituminous system in rolls spread on the surface has been very, very common for many years and is still used today. But then over the waterproofing system, upon the waterproofing system, we have the screed, or sometimes we have the bed of mortar where we will place the tiling. Is this a proper way to fix tiles? We can say, yes, it's been used for a long time and still used today for the application of some special kind of tiles and natural stone. But we have to say that this kind of system, this kind of stratigraphy becomes very suitable, let's say like this, when the thickness of the stone or the tile is higher than a certain value. Because if I try to apply a thin stone, a thin tile with this system today, I will face some problems of stability. But bringing back to the point of efflorescence, there is another thing that we have to consider here. When it is raining, of course, when it's snowing, raining, when there is water on the surface of the floor, do you think, is there any chance to avoid water penetrating under the tiles? We tried and tried many times to find some solution for this, but the reality is that water will always penetrate through the joints that we see between each tile. Some might say that if we apply into the grout a watertight system, somebody thinks of a very watertight cement or watertight resin systems to block the water to the level of the grout. Well, we also tried that. But it's not really possible, because if we check the detail to microscope, electronical microscope, the edge between the tile and the grout that we think will be watertight system, no way to stop the water penetrating to the thin porosity of the tile, which is never perfectly right, never perfectly regular, and water will drop in. So this is just to say that if I don't want the water penetrating under the tile, it will be very, very difficult by the grouts between the joints, even if I use a watertight system. In this case, the water will penetrate under the tile. And consider, I was forgetting a detail that can be interesting for you. The international standard, every country has a local standard, but international standard declare that the waterproofing system, to be a real waterproofing system, should be a continuous layer. So it's common sense tell us that the grout between each tile cannot be a continuous system. So let's forget about this possibility. No way to really stop the water into the grout. But once the rain, the water pass under the tile, it will find the screed. The water will find the screed, or will find the bed of mortar that I have used to fix tile. Good. Then we'll drop down until the waterproofing system. And if I made the slope, the water will go out through the slope to the drainage system. A significant part of the water will be evacuated this way, but another significant part will remain into the screed, will remain into the bed of mortar that I have used to prepare over the waterproofing system, the support for the tiling. And all this water somewhere will go out. And where do you think it will go out? Which is the exit way for the water trapped into the screed when it is evaporating? Well, the same to get in, the joint between the tiles. And this is why we see all over the joint and the grouts, we see the white spots, because the elements into the cement-based system will be brought up to the surface in contact with the CO2, will become calcium carbonate. So in this way, a first possibility, a first solution, and let me say a modern solution that we can try to adopt to avoid this kind of problem could be this. Why don't we place the waterproofing system over the screed and not behind the screed? If we have the chance to place the waterproofing system over the screed and not behind, everything under the waterproofing system will be well dry. Because when it is raining, or when water is dropping on the surface of the floor, then they will penetrate through the joints, but immediately will get in contact with the waterproofing system, and with the slope will be evacuated, and everything behind the tiling will be dry. So we will not have any evaporation of water through the joint of the tiling, no efflorescences. And think in winter time, for example, we can have freezing of the water trapped into the screed. In this case, no water will be trapped under the screed, into the screed. Then there can happen some cracks, but in this case, with the waterproofing protecting the surface of the screed, no water will penetrate into the screed. So if we have the chance to apply the waterproofing system over the screed and not below the screed, then we can make a first important step to avoid the formation of efflorescences, or let me say better, not to have water under the tiling, which is the first main causes of staining and efflorescences. So in this case, in this stratigraphy, just an example, but here you can see some other important details. One of them I already told you before, the slope, because the slope is a technical detail, very important to evacuate the water. The second point that you can see is that onto the waterproofing system, here I can fix directly the tiles. The point number 3 that we can see also in this detail is that at the end of on the edge of the terraces, we have a marble finishing, but just close to the marble we have tiles. Now the question is, the marble and the tiles, when they get in contact together, do they have the same deformability? the same coefficient of deformation? No, they don't. They will move a little bit differently. So in this case, you see, we have a natural neutral sealant. So it means here, it means a deformable sealant. Normally a silicone can be applied in this place, a waterproofing silicone, but it's important to avoid the formation of any crack. Now, these are just details that maybe we'll have the chance, I hope in the future, and all with the colleagues, you can discuss in deeper. Let's remain focused on the waterproofing system. If I apply the waterproofing system over the screed, I cannot use, for example, the bituminous membrane. Or let's say better, you can use it, the bituminous membrane, but in this case, we have to remember that onto the bituminous system is not possible to fix directly tiles. Onto the bituminous system, we usually lay down the screed, lay down the mortar of bed, and lay down the tiles. But we don't fix it. In this case, if I want to place the waterproofing over there and I want to fix tile, I will slide my fixing of the flooring by using an adhesive system. Thinner mortar, thick bed of adhesive under the tiles. In a few minutes, we will go to see in details this application. What kind of waterproofing system so I can use over there? Well, one of the most common waterproofing system can be applied over the screed can be a cement-based flexible and waterproofing system. Here you can see an example. The name of this system in particular is called Mapelastic. Of course, it's done by Mapei, but the idea is more important of the name of the product. Here we have a cement-based flexible system. In fact, the Mapelastic, the mortar that you can see applied by trowel, by rolls, by brush, can be applied in different way. It's a cement-based system. And it is a waterproofing system, can be applied directly over the screed, and we place all over the corner, all over the angles, and all over the drainage points, or to the joints, expansion joints, we place a tape made of rubber to reinforce and watertight exactly that point. Because on terraces, on decks, the most difficult part to watertight are the angles, the corner, the joints, the changing of slope, all of these points, the structure is moving a lot. So we need to, first of all, watertight that point. The Mapelastic system is done by 3 elements. The mortar that you can see, apply over there. Then we have the tape, and then we have the mesh. The mesh, fiberglass mesh into the mix of the waterproofing. We use the mesh to reinforce it in case of any movement that can occur on the substrate. In this way, we apply a completely continuous waterproofing system, and onto the waterproofing system, directly onto the waterproofing system, we can fix tiles or stone, keeping dry everything which is below. The Mapelastic in particular is a deformable system. Deformable system means that allows a movement of the substrate in 2, 3, 4 millimeters without cracking. This is an extreme test what we did with the Mapelastic system to show that even a low temperature, high temperature, the deformation of the system remains very, very high. Is this an important tips? Yes, can be, because if we have a substrate with some cracks, or we are afraid that can be some cracks on the flooring, some movements, the waterproofing, elastic waterproofing system will not be broken and will keep the watertight of all over the system behind. The Mapelastic is a system that was born to protecting the concrete. In the beginning, we used the system to protect the pillars of the bridges of a very huge concrete structure. But then, since Mapelastic is resistant to water and resistant also to the aggression of environmental conditions, snow, wind, rain, salts, is resistant to the aggression of all of these things, then we adopt the same solution for balconies, terraces, decks, and huge surfaces in private and public application. And the system can be applied not only, the membrane, the cement membrane can be applied not only onto cement, but if you have an existing flooring, an existing tiling, which has some problems, maybe some cracks, maybe some leakage that drop down in the roof, and you don't want to remove everything. You want to leave over there the tile on the surface. Okay, no way to remove everything. We can apply the cement-based thin waterproofing system, only 3 millimeter thickness all over the surface, and then over it, we apply the new flooring. Sorry. So just to recap some advantages. As I told you, all the substrate is protected from water, no rising vapor, no efflorescences, no freeze-thaw cycles for the substrate, a compensation of the cracks in case you have some cracks on the surface, and direct fixing with no thickness of the new flooring on the surface. The MAP elastic in this case has been used in plenty of job sites with all the components, by the drainage, by the reinforcement tape for the corner and the edges and the angles, and the MAP elastic itself. You see on the right, we have the proper stratigraphy that we may think to project in a balcony or terraces. We have the concrete, the screed, and then the waterproofing system. If I place the waterproofing system under the screed, well, I will protect the concrete, but I can have a better protection, a higher level of protection if I have the chance to apply the waterproofing over the screed and not right behind it. So with this system, so with the idea of trying to change the position of the waterproofing system, applying it just right behind the tiling, we have solved a lot of problems in many job sites concerning the waterproofing system and the efflorescences coming through the joints of the flooring from the substrate. Anyway, the waterproofing system applied in this way is one part of the talk. You know, you work in construction field, so you know there are some other details that we may check. For example, how can I reduce the water contained into the mix that stays behind the tiling? We said in the beginning that one of the main problems coming from the efflorescences is that there is water under the tiling, a lot of water. How can I reduce that? Well, consider that a normal cement, a Portland-based cement, a Portland cement screed requires 7 days for each centimeter to reach a suitable residual moisture into the compound, not to affect the flooring. So it means that if I do 4 centimeter thickness of bed of mortar with a Portland cement system, I will need 28, 30 days without considering the amount of water that I am putting inside, because if I mix too much water, it's even worse. But these are long time. How can I reduce the timing, the waiting time to reduce to reach the proper residual moisture and to reduce the amount of water into the mix of the screed or the bed of mortar? One way is to adopt, for example, the use of acrylic-based plasticizing admixture. These are special chemical components with a poor dosage, just 1.5 kg for 100 kg of cement, that mix into the compound, produce 2 effects. The first one is reduce the amount of free water into the compound. And if I reduce the free water into the compound, I have to wait less time before fixing tile, or I have a less shrinkage of the system, of the cement, because during the setting time and the curing time too, there is a shrinkage happening into the cement compound, and this shrinkage can produce some cracks. The admixture can reduce the amount of water, so reducing the frequency and the phenomenon of cracking of the surface. This is one solution that can be considered. Think of this next time you have to make a decision on how to prepare the screed. If I want to reduce the water inside, maybe I have timing to consider or a special job site, I can think of this. A very poor percentage can produce a very good reduction of water. And second thing, will increase the mechanical performances. Actually, the second result is just the consequences of reducing the ratio between water and cement. In this case, we improve the mechanical performances of the screed. There is another possibility, which is the second one you see here, to reduce the water under the tile. And it is using special binder. Special binder means all those binder, normally cement binder, not Portland, not normal cement, but cement that can reach and reduce the water with a residual moisture lower than 2 or even 3% in only 2, 3, 4 days. Just to give you an example in our family, but you will find by making a research for your own, you will find family like this. I give you just name, but the name is not important. Thompson Pronto is a screed, ready-to-use screed. What is matter the most in this case is that the residual moisture after 24 hours, only 24 hours, is lower than 4%. This means that waiting time for fixing tiles on the Thompson screed will be only 24 hours. If you think that a normal cement to eliminate the water into the mix requires 7 days for every centimeter, in this case, with a special binder or a special screed like Thompson Pronto or Thompson, well, all these timing are decreased a lot. In only 24 hours or a couple of days, you can fix tiles. And you may say, well, I don't have this kind of needs because I can fix tile even after 1 week, after 10 days. Yes, okay. But consider that if the amount of water into the substrate, the bed of mortar or the screed is higher than this value, not today, but maybe tomorrow, maybe in 1 week, you will face one of the problems that we have seen. Efflorescences, cracking, shrinkage, passing of water, detaching of the tiles, and in some cases, damaging of the surrounding elements of the terraces or the balconies. So the usage of this kind of material is very simple because it's like all the other screed or cement-based mortar that you may use in the job site. Let's stop 1 moment to make a checkpoint on what we have seen since now. We start talking of these problems about the Efflorescences. Now we have at least 2 options to consider on how to eliminate or reduce or eliminate this kind of problem. The first one, as we told, is place the waterproofing system over the screed. The second one is, as we just saw now, reducing the water into the mix by means of a mixture or a special mortar, a special binder that provide me residual moisture lower than certain value. And we don't have to forget that these are 2 options that have to be combined, since maybe you are designer, project designer, and you have the chance to take a responsibility for this, which is an important part. Consider the other factors that we just mentioned, the slope, the full body coverage of the back of the tile without voids under the tiling. Also, this part is very important when I choose the method to fix tiles. So in this way, from today on, we have at least 2 ideas on how we can stop or reduce the formation of efflorescences on the flooring. And for any further detail on this stratigraphy and method system, MAPEI is available, and of course the local colleagues are always available to go deeper in this detail. This part about the water containing the substrate and the protection with a waterproofing system is of course linked to the quality of the substrate, because another problem that we normally face with our customer, I have to say not all of them, only in the cases where we have some defect on the surface, we discover that apart of the efflorescences, another common defect is the poor quality of the substrate. Poor quality of the substrate means a lack of cement, for example, or do you know when the applicator make the screed and then try to make a very smooth surface on the floor and then apply water and cement to make a smooth and perfect planarity on the surface, imagining that this will be appreciated for the fixing of the natural stone, of the tiling on the terraces. Yes, will be appreciated by the aesthetical point of view, but the thin layer that you have done with cement and water of the surface will be detached. So also this is part of poor quality of the substrate. And as we told, high percentage of water, the touching elements and everything. All these defects can create a huger problem when water is coming. Just to give you a referential idea on what are, by an international point of view, the minimum requirement foreseen for the substrate for fixing tiles, and natural stone is very close, is the same, more or less the same application. For example, in Italy, we have a standard that requires a minimum of 16-20 Newton for square millimeter, which is 150, 160 kilogram for each square centimeter as compressive strength for the substrate for fixing tiles or stone, but into residential, private application. If I go for industrial environments, I will have to reach even some more, 30 Newton or 40 Newton sometimes, 300 kg for each square centimeter to fix tile in environmental, like industrial application, or even those application when I know that will be a load passing on the surface, can be a pedestrian, but for example, if I make a shopping mall, or if I go the beach of a swimming pool, something like this, in this case, I need to reach higher value of mechanical compressive strength. Now, to reach this kind of value, of course, we have to pay attention in the project, writing in the project that we require, according the classification of the mortar for screed, the European standard, for example, is 1380-13. It's just a referential part. Maybe you can check locally what is in your country, in your region, let me say, the referential values for this kind of application. But according to this classification, in our project, by designing or just selecting the type of material that should be used in that job site, we can do a good choice by including the value of compressive strength required for the substrate. Of course, once we say that, then there is the application part. The application part phase, the application part, sometimes is out of our control. Of course, the application are doing the job as they know, as they think is better for them, and we appreciate very much the knowledge and the skills of many applicators. But when it happens, this kind of problems, we have to consider that something was wrong also in the application. Let's give a look, for example, to a very, very common substrate, the screed. The screed is a substrate that we use to lay down everything. Tile, stone, wood, resin, sportive flooring, whatever is normally placed over the screed. So the screed should have some characteristic, not a perfect screed, but some characteristic fundamental, just to put some detail on the table so we understand. If I have to do a screed, or let me say a substrate, a support, and I have only 1 or 2 or 3 centimeters available in the job site to do the substrate, can I do a screed? And if yes, what kind of screed between all of them I can do? Well, in this case, I will do the bonded screed because 1, 2, 3 centimeters lower than 4 centimeters, I need to fix the screed at the substrate by means of a latex or a resin. And what if I have in the job site, for example, a thermal isolation panel? Or what if in the job site I have an acoustic membrane under the screed? what is the minimum, for example, thickness, what is the minimum requirement that I need for the screed. In this case, when I have a flexible material under the screed, like a panels for thermal isolation, then I need to have minimum 5 centimeter thickness of the screed, and not only, I need to have a reinforcement with a metallic mesh placed in the middle of the screed to distribute, to spread the load coming up onto the screed, because below I have a deformable system, and so on. We have to pay attention to these details. The heating screed, I don't know if in your case you manage this kind of heating screed, but what is the minimum thickness suitable over the pipes, over the tube that I need to have to make a proper screed without cracking? All these details normally are given to the applicator, hoping that they know, and many of them, they do a very excellent job. But sometimes it happens that these details are not known. And apart the water into the mix, then we will have cracks and detaching and debonding at the level of the screed. And when we have something like this at the level of the screed, as we saw before, everything will pass in. Water, detaching elements, and we will have early debonding of the final floor that we place over it. So let's pay attention to these details that are not separated from what we have seen since now. Many times it happens that we leave to the applicator the choice of the expansion joints, where I have to do the expansion joints on the screed. They cut the screed, they properly cut the screed within the 24 hours after the preparation of the screed, but honestly, as far as our experience, the positioning, the design of the joints over the surface is not a matter of applicator, it's a matter of project designer. What is an expansion joint? What is the difference between expansion joints and control joints and structural joints? How can we suppose that the applicator knows this kind of detail? How can we suppose that the applicator knows the technical detail of the tiles, of the stone, of the screed that we are going to use? And if we don't do any expansion joints, then we will have a crack. And when we have a crack, a problem on the screed, on the level of the mortar, then we have the bonding of the floor. Water will penetrate and everything will be early destroyed by a defect that was up to a project phase. This is just an example on how to project a joint. We cut it for 1/3 of the total thickness of the screed, and then there is a ratio between the depth and the width of the joint itself. In this case, we have the ratio is A/2, so the depth of the joint will be normally half of the width of the joint, and in this case, we will have a good deformation and proper working of the sealant silicone that we will use into the joint to allow the movements of the floor without having cracks. If I don't do the joints, I will have crack on the surface. And once I have done the expansion joints on the screed, in this case, they were done. What is the problem here? The problem is that they fix tiles crossing the joints. In this case, we will have all the detachment of the tile placed right on the line of the expansion joints, because the joints, once it's done, should be respected. Should be the tiles should be applied on the both sides of the joints, but not crossing over it. If I want to cross over the joints, I need to close it. But honestly, this is another chapter. It is always linked to the preparation of the substrate. And to give an help to the applicators and also in the project phase to avoid all these problems that we've seen, so the cracking, the fluorescences, the lack of mechanical performances, we can adopt a special binder, as we said, or an admixture, or even somebody, this is a technique used in the last more than 10 years, but it's suitable. We can mix fiber into the mix of the compound. The special binder are already fiber reinforced. But if I make a screed made of cement Portland system, I can adopt the fiber into the mix to reduce the cracking, to increase the mechanical performances Of course, according to the type of job site I have to do. In a deck, in a terraces, in a huge surface, I have to consider that the percentage of fibers that I use into the mix do not have to affect the workability of the system. In fact, normally fibers and admixture may be used together to maintain the workability of the system of the screed when we apply and when we mix the fiber into the mix to increase the behavior of the material. And the last thing we have to mention, and it's very the last thing, just suggestion that we can share together in this presentation, is a reflection on the tile. The tiles have changed. The tiles have changed, and nowadays we have less and less absorbent tiles. The grass tiles can be considered not absorbent, but the single fire, the double fire, on the back, on the rear side, they can absorb a lot of water. So the first two types of tiles, the double fire and the single fire, has been for a long time, has been fixed by means of a fresh slurry bond coat on the surface, fresh cement on fresh substrate, with the potential problem that we have seen about efflorescence. But since the back is very absorbent, it's been common find on the job site and building site this kind of application of fresh mortar. But since now the grass tile has been producing large format tiles, and since they are less and less absorbent, we have to put ourselves a question. Can I apply such a not absorbent tile in a bigger size as with a normal way, so-called traditional way? This is a difficult answer to give. This is a difficult answer to give because we may say it depends on the habit of the local market, but the truth is that I can use a traditional way to fixing tiles, which is a good application if it is well done, when I have tiles or stone with a certain thickness of the slab. Because if I reduce the thickness and I reduce the absorption, the traditional way to fixing tile can have some stability problem, apart from what we have seen since now about all the water inside the substrate. This is why today, more or less everywhere, we find the new family of, not so new anymore, I have to say, the method of applying tiles by thin bed mortar, which is adhesive tiles. And the adhesive tiles that are cement, special cement binder, can give you the opportunity to have a much higher adhesion of even thin tiles, even not absorbent tiles, onto the substrate, even if it is a waterproofing system. Then we can reduce the waiting time before go in service onto the flooring, onto the terraces, on the deck we are preparing, because in only 1 day, 2 days, if we match together the propping system by means of thin set mortar, like an adhesive, in only 24 hours, 2 days maximum, we have the chance to use our surface. It's not only a matter of using the surface. What we want to focus is without problems concerning weakness of the substrate, efflorescences, and detachments. This is our main goal when we make the application outdoor over large surfaces with tile or stone. So take into consideration this possibility. Maybe you have a job site when you want to try, or you already do that and you already discover the advantages of using an adhesive system to set down the tiles and the natural stone without staining and efflorescences. If you don't have, take the chance in your project to see this opportunity, because can save you by aesthetical defect and also technical one. So I'm going to conclude, to close my presentation, just saying that the terraces, the balconies are very, let me say, outdoor application, difficult environmental, where water is one of our biggest friend and biggest problem. We need water to prepare all the substrate and everything we need, but we have to avoid the presence of water passing through the joints and going down can create problem to our flooring. And to do that, we can place the waterproofing system just under the tiling, so no water will pass through, no efflorescence will rise to the joints, to the drainage. All the system behind the tile will be completely dry. And second point, we have to pay attention and consider on the performances of the substrate, because any crack, any detachment due for example, lack of cement, lack of expansion joints, or defect during the application with the thickness of the screed and cement support, all these things can create a problem, a bigger problem to the surface by the same way we have with efflorescences and detaching. The balconies and the terraces, whatever they are, private, big, small, they have all the same conception to have to consider. We have seen some of them. If we have time, if we had time, maybe we will have the chance again to meet, to focus on some other details. Today we have seen the fixing system, the waterproofing, but consider the chance to have special grouting, how to manage the details like the breaking point into the thickness of the stratigraphy of the waterproofing or the thickness of the screed or the concrete itself. And what about the right placing of the joints, etc., etc. So all these things will help us to make something that stays and lasts as long as possible. I really hope that this kind of information, these are just tips, just point on you can reflect on and think if you have the chance to adopt some of them. We, as MAPEI, with our technical service, local technical service headquarters, always are very interested in knowing how you do this kind of application to update also our system to propose to the market and to you. But so we need a real feedback from you on this. And by your side, if you find some interesting point or idea, or you have any doubt, please do not hesitate to contact our local colleagues, or if you want to write directly to us, there is no problem. So I finish my presentation. I thank you very much, all of you, for the attention that you have paid to this presentation. Thank you very much for our colleagues in MAPEI to give us from the headquarters to have the chance to be here with you to share this information. Thank you very much also to CIS for the technical organization of this system. We keep in touch by local colleagues, and online on the MAPEI online exhibition stand, you can also put your question. And by my side, that's all. Thank you very much, and I hope to see you soon again. Bye-bye.